In class example 1.36, we're asked to use our knowledge of horizontal and vertical stretches to determine which stretch has occurred in each case and by what factor. We'll then use that information to determine the mapping rule and the equation. Now, in our first example on the left, part A, we see a dark blue or maybe black graph, y equals f of x, and its transformed version in green, y equals g of x. We've already been told that the transformation that occurred was a stretch, so we just need to determine if it was horizontal or vertical. Well, in some cases, it's really obvious, and you might be able to tell here because the graph kind of looks thinner. But what we really want to focus on are the invariant points. Did the x-intercepts change? Did the y-intercepts change? And here we see that the one pair of corresponding points that have not changed, which is really an invariant point, is the y-intercept. When I say corresponding points, if we look at, for example, in one of the end points, we can see that on the transform graph, it's not in the same place as it was. And similarly, when we look at the x-intercepts, we can see that they correspond to a different position. However, the y-intercept is the same on both the original and the transform graph. So now that we know that it is a horizontal stretch, we want to know by how much. To determine the stretch factor, we will compare two corresponding points. In this case, it won't be helpful to use the invariant points because they haven't moved. So let's look at the endpoint. The farthest right point, or rightmost point, on the graph of f of x is 8 units from the y-axis, horizontally, of course. And the corresponding point on g of x is 4 units from the y-axis. Now be careful, we're not talking about translation here, so we don't want to say they're 4 units apart. That won't be helpful. What we want to determine is what the 8 was multiplied to change it to a 4. So 8 multiplied by some horizontal stretch factor became 4. A quick division of both sides by 8, and we see that the stretch factor is 1/2. Now remember, the stretch factor shows up as it is in the mapping rule, which is to say, if the stretch factor is 1/2, we'll see the coefficient of 1/2. So here our mapping rule is that xy becomes 1/2 x and y. However, because this is a horizontal stretch, it corresponds to the b parameter, so the coefficient in front of x. And we remember that there is a reciprocal relationship between the stretch factor and the b value. So here, f of 2x would be the parameter that would lead to the stretch of 1/2. Having worked through example A, you can probably handle B on your own. Why don't you give it a try? Can you determine the mapping rule and the equation for g of x? Well, as stated before, the first thing to do is determine whether this is a horizontal or vertical stretch. We note right away that this graph has 3 invariant points, this transformation has 3 invariant points, and all of them are located on the x-axis. This means the graph has been stretched vertically. Now we need to find any 2 corresponding points to determine the vertical stretch factor. Well, let's use the y-intercepts, which are clearly marked on this one. On f of x, and it is important to determine which one was the original, on f of x, our intercept was 6 units above the x-axis. While on g of x, it is 9 units above the x-axis. Again, we don't want to talk about it going up 3 because that treats it as translation. We want to know by what factor do you multiply 6 to generate a 9. So 6 times the vertical stretch factor becomes 9. We can isolate the vertical stretch factor to determine that it is 3/2. Now you notice here, I didn't use the letter A, even though I could have. This is mostly because we aren't certain if A is positive or negative. And in the case of the horizontal stretch factor, it corresponds to 1 over b, and writing 1 over b can lead to student confusion. So we just used VSF here for vertical stretch factor and hope that that's satisfactory. Well, because that vertical stretch factor is in fact the A value, we will write the mapping rule of xy becoming x and 3/2 y. You could also write 1.5 there, because what you see with the vertical stretch factor is what you get as your A value. Similarly, when we write the equation, we talked earlier about how replacements would make this show up as the reciprocal of 2/3, but typically when we write the equation, the A value appears on the right side of the equation in front of f and as its true horizontal stretch factor value. So here, g of x to be equal to 3/2 f of x.